Okay, so for this chemical equation, we have phosphoric acid reacting with potassium hydroxide and producing potassium phosphate in water. What's special about this chemical equation is that you have the same polyatomic ion appearing in the reactant and then in the product side. So whenever you have the same polyatomic ion that appears on both sides, you keep it together as a single unit whenever you balance the chemical equation. So I'm going to circle it just to remind you that we need to keep it together if it appears in the reactant and in the product side. And basically, a polyatomic ion is a group of atoms that are stuck together that has a charge, but the charge is usually not displayed in a chemical equation. So now, let's find out how many atoms do we have in the reactant side. So I know we have hydrogen. And then we have 3 plus 1 gives us 4. And then we only have one polyatomic ion. Now, if we have more than one, it's going to be understood by having parentheses, and then it's going to have a small subscript that is going to have either 2 or higher. So we know that for this one, we only have one polyatomic ion because it doesn't have parentheses. So we have only one phosphate. And we know we also have potassium. And we only have one of them. And then we have one oxygen. Remember, this is not part of it because this is seen as one group. And then we already counted the hydrogens a few minutes ago. Now, on the product side, we have 2 hydrogens. And then we also have one polyatomic ion, which is phosphate. And then we have 3 potassiums. And then we have one oxygen. So now we need to identify the loner. The loner is the one that appears by itself, is not part of a compound. And then in this chemical equation, we do not have a loner. So we're going to move on to see if we can identify the 1:1 ratio, also known as the pair element. And that is the element that appears one time in the reactant side and one time in the product side. So hydrogen, it appears 1 and 2 times in the reactant side. So it's already a no. I'm not going to put a check mark on it. And then phosphate, it appears 1 time in the reactant side and 1 time in the product side. So I'm going to put a check mark. And then potassium, it appears 1 time in the reactant side and 1 time in the product side. So I'm going to put a check mark. And then oxygen appears 1 time in the reactant side and 1 time in the product side. And then we already talked about hydrogen. So now we're going to start with the largest 1:1 ratio, also known as the pair element. And this is the element that has the largest subscript. So out of the ones that we put the check mark on, the one with the largest subscript is going to be potassium. Notice that we have 3 potassiums in the product side and only 1 potassium in the reactant side. So what I'm going to do, I'm going to put a 1 in here. And 1 times 3 gives me 3. So therefore, I need to have 3 over here. So I'm going to come over here and I'm going to put a 3. So therefore, I have 3 potassiums on both sides. So I can check that off and I can mark my potassiums. Now, I know I have 1 phosphate in the product side. So therefore, I need to have also 1 phosphate in the reactant side. So I'm going to lock it in with a coefficient of 1. So I'm done with the phosphates. So this is checked off as well because they're balanced, the phosphates. Now, whenever I put this one in the coefficient, it lock also the hydrogen. So 1 times 3 gives me 3, and then plus 3 from over here gives me a total of 6. So I have 1 times 3 gives me 3, and then 3 from here gives me a total of 6. So I can mark my hydrogens. So now we have to come over here for the hydrogens. We have 2, and I need to make it a 6. So therefore, I'm going to put a 3 in the coefficient. 3 times 2 gives me 6. And that is balanced as well. And the only thing that is remaining is the oxygens. So I have 3 oxygens. And then I also have 3 oxygens. So at this point, everything is balanced.